Hello, I am Dr. Srisruba Bharali and I welcome you to this lecture video on Introduction to Scilab Environment, which is a part of the online course on open source software for academia. In this lecture video, we will explore the features and capabilities of Scilab in detail. We will also compare Scilab with similar numerical computing environment such as MATLAB, highlighting their differences. Additionally, we will introduce you to the basic syntax and essential commands used in Scilab. This lecture will also cover fundamental topics like handling .sci files, executing script files, and working with mathematical operators and constants. Furthermore, we will guide you through the process of installing and removing packages in Scilab, enabling you to extend its functionality as needed. By the end of this video, you will have a solid foundational knowledge on Scilab. Scilab offers a comprehensive set of tools and functionalities that make it a powerful open source platform for numerical computing, data analysis, and algorithm development. One of the most essential features of Scilab is its metric-based computation. Scilab is fundamentally designed around matrix-based operations, making it an ideal tool for handling linear algebra, statistical computations, and numerical methods. Since matrices form the core data structures in Scilab, users can efficiently perform operations like matrix multiplication, inversion, and eigenvalue computations. One of the key features of Scilab is its extensive mathematical functions. Scilab comes with a vast library of built-in mathematical functions covering calculus, which includes functions for differentiation and integration, optimization, which includes tools for solving linear and nonlinear optimization problems, differential equations, which include solvers for ordinary and partial differential equations, and Fourier transforms, which includes functions for signal and image processing applications. One of the standout features of Scilab is its data visualization capabilities. Scilab provides extensive data visualization tools to help users analyze and interpret data effectively. Some of the key graphical capabilities include 2D and 3D plotting, which is used for plotting line graphs, scatter plots, and surface plots. Histograms and bar charts, which are useful for statistical analysis. Contour and density plots, which are ideal for representing mathematical functions and data distribution. And graphical user interface support, where users can build custom visualization and interactive plots. One of the prominent features of Scilab is its capability for programming and scripting. Scilab supports structured programming, allowing users to write scripts and functions for automation, data processing, and numerical computation. Key programming features include control structures, user-defined functions, and script execution, where users can write script files to execute multiple commands in sequence. Code debugging is also included, where debugging tools are used for error detection and performance optimization. Another significant feature of Scilab is its package management system, which allows users to install, manage, and remove additional packages to extend its functionality. The automatic toolbox management for Scilab, or the ATOMS system, simplifies the installation of new toolboxes, making it easier to integrate specialized tools for various applications. Additionally, Scilab supports third-party extensions, enabling users to develop, distribute, and customize their own packages to meet specific computational needs. This package management feature includes various specialized toolboxes that enhance its functionality across different domains. Some notable toolboxes include Signal Processing Toolbox, Control Systems Toolbox, Image Processing Toolbox, Machine Learning Toolbox, and many more. The Signal Processing Toolbox can be used for filtering, spectral analysis, and wavelength transformations. The Control Systems Toolbox can be used for designing, analyzing, and simulating control systems. The Image Processing Toolbox is used for image enhancement, filtering, and feature extraction. The Machine Learning Toolbox includes basic tools for data classification and clustering. Scilab also offers users the platform to develop custom toolboxes and share them with the community. One of the notable features of Scilab is its ability to interface with other languages. Scilab offers seamless integration with multiple programming languages, making it a highly versatile tool for interdisciplinary projects. It supports C and C++ integration, allowing users to call C++ functions directly from Scilab for performance-intensive tasks. Additionally, it provides interoperability with Java and Python, enabling smooth interaction with applications developed in these languages. Scilab also supports external libraries, allowing users to load and utilize additional functionalities, further enhancing its computational and analytical capabilities. While Scilab is primarily designed for numerical computing, it also supports symbolic algebraic computations through the SkyMax toolbox, which integrates Maxima, which is an open-source symbolic computational engine. This integration enables users to perform symbolic differentiation and integration, solve equations, and handle matrix algebra with symbolic elements. These capabilities make Scilab a valuable tool for analytically solving complex engineering and mathematical problems. Overall, Scilab is a powerful numerical computing environment with a rich set of features that make it suitable for scientific research, engineering applications, and educational purposes. Now, let's examine how Scilab compares to MATLAB. Scilab is mostly compared to MATLAB because it is a free open source alternative that provides similar numerical computing and simulation capabilities. Comparing with MATLAB, Scilab has the following advantages. Scilab is completely free and open source software, making it an accessible choice for students, researchers, and professionals without any financial constraints. In contrast, MATLAB requires a paid license, which can be costly, especially when additional toolboxes are needed for specialized tasks. Secondly, since Scilab is open source, it allows users to modify, extend, and customize the source code according to their needs. In contrast, MATLAB is a proprietary software, restricting users from accessing or modifying its internal algorithms. Third, Scilab provides most of the functionality required for numerical computing, including matrix operations, signal processing, optimization, and data visualization, similar to MATLAB. Fourth, while MATLAB requires a paid license for Simulink, which increases the overall cost, Scilab includes Xcos, a powerful graphical simulation tool similar to Simulink, allowing system modeling and simulation at no cost. In terms of research uses, Scilab generally consumes fewer system resources than MATLAB, making it a suitable source for users with lower-end hardware. In contrast, MATLAB can be resource-intensive, particularly when handling large computations and graphical interfaces. In terms of license restrictions, Scilab can be freely distributed and installed on multiple systems without any licensing issues, whereas MATLAB requires a valid license, which is often restricted to a limited number of installations. In terms of community contributions, Scilab has an active community of developers and users who actively contribute to its development and share custom toolboxes and scripts. In contrast, while MATLAB has a larger user base, its proprietary nature limits external contributions to user-created toolboxes. In terms of built-in functions, Scilab provides a wide range of functions for scientific and engineering computations, minimizing the need for additional toolboxes. In contrast, MATLAB often requires the purchase of additional toolboxes for many advanced functions. Scilab is a great alternative to MATLAB, especially for users looking for a cost-free open-source numerical computing environment with simulation, data analysis, and engineering tools. While MATLAB remains a powerful industry standard, Scilab provides a viable solution for students, researchers, and engineers who need powerful computing capabilities without the cost of commercial licenses.
Let us take a moment to assess your understanding with a couple of quick multiple choice questions. This will help you review and reinforce what we have covered in this tutorial. Here is the first question. What is the core data structure in Scilab? Take a moment to think about your answer. The correct answer is option B, matrix. If you got it right, well done. If not, don't worry, you can revisit the explanation in the video. Now, here's the second question. What is Scilab's alternative to MATLAB's Simulink? Take a moment to think about your answer. The correct answer is option A, XCOS. Now here's the next question. What is the purpose of Scilab's data visualization tools? Take a moment to think about your answer. The correct answer is option B, to analyze and interpret data. Now let's look at the next question. What does Scilab's scripting capability allow users to do? Take a moment to think about your answer. The correct answer is option C, write scripts and functions for automation. Now here's the next question. What is atoms in Scilab used for? Take a moment to think about your answer. The correct answer is option D, installing, managing, and removing additional packages. If you got the answers right, good job. If not, don't worry, you can revisit the explanation in the video.
Let us now look into the basic syntax and essential commands that are used in Scilab.
Before diving into the basic syntax, we will explore the Scilab environment. The Scilab environment consists of the file browser, which is on the left, the Scilab console, which is at the center, the variable browser, command history, and news feed, which are on the right hand side. The variable browser always displays the variables that have been created, while the command history lists the commands that have been used so far. In the Scilab console, after the arrow prompt, just typing a command and pressing enter will give us the result of the command. For example, if we type 4 plus 5 and hit enter, it will give us the result, which is 9 in the default variable ans. We can also see that the variable name ans has been created here in the variable browser and it stores the value 9. We can also assign values to variables in the console. For example, we can assign the value 5 to the variable a. If we do not end the assignment with a semicolon, the variable's value is displayed in the console window. However, if we assign a semicolon at the end, then the value is not displayed in the console window. For example, here we can see we have end this with a semicolon, so the value is not displayed. We can also use several commands in the console. For example, the command clc can be used to clear all the display in the command. So when I give clc and enter, it asks me if I want to clear the console and I hit yes. Another command is clear, which will remove all the variables in the variable browser. So when I give clear and hit enter, all the variables in the variable browser has been removed. Now let us look at the different mathematical operators that can be used to perform mathematical operations in Scilab. There are addition, subtraction, multiplication, division and exponentiation. We have already seen an example for addition. Similarly, we can perform other mathematical operations in the console, such as subtraction, multiplication, division and exponentiation. For example, entering the value 5 multiplied by 6 will return us the value 30. The new result is automatically stored in the different variable ends. Let us see an example for exponentiation. 5 to the power of 2 will return us the value 25. Now, let us look at the different constants that are available in Scilab. In Scilab, certain special variables have predefined values and are known as predefined constants. These constants have fixed values that cannot be modified. To access these variables, the percentage symbol is used, followed by the variable's name. For example, percentage pi is used to represent the value of pi, which gives the ratio of the circle's circumference to the diameter and is 3.1415927. Percentage INF is used to represent infinity. Similarly, percentage E is used to represent Euler's constant, which is 2.718218. Similarly, there are many other constants that are defined in Scilab. When writing commands in the console, the commands cannot be saved, and editing multiple lines of these commands is also not convenient. A sci file is a script used in Scilab to store these commands or instructions. It primarily serves as a function file beginning with a function statement. Additionally, it can contain multiple function definitions, each executing various Scilab commands on function arguments. To write multiple commands, we can use the SkyNotes tool available in Scilab. To open SkyNotes, we can either click on the first icon in the toolbar. So here we can see that the SkyNotes have opened. Alternatively, we can also go to applications and go to the SkyNotes part here, and when we click on this, again the SkyNotes will open. So this will open the default file name, which is the name untitled1. We can write our commands and functions here. Once we have written our commands and functions, we can save the file using this option, using save option, or we can also go to file and then click on save as, and then we can give a suitable name, for example file1.sci. To run a saved.sci file, we can click the triangle icon in the toolbar. So let's see that. We have opened this file. And then we can see here the triangle icon. When we click on this, the file is going to be executed. Here it is asking me, since the command here is clear and CLC, that if we want to clear the console, and we are going to give the option yes. So here we can see these two commands have been executed. In Scilab, we can add many additional packages or modules called as toolboxes, which have been created by the Scilab community. ATOMS, which stands for Automatic Modules Management for Scilab, is the repository for these packaged extension modules. Scilab includes a GUI to facilitate the use of ATOMS. To access the GUI, we can either click on the box item, which can be seen here, or we can go to the applications in the menu bar and select Module Manager ATOMS here. When we click on this option, then the GUI will be opened. So here we can see the GUI for the packages is being opened. Let me close this now. We can also type ATOMS GUI command, which will also launch the GUI for the packages in the console. Let us now try to install a package. For example, if I want to install the package for artificial neural network, then I can download the ANN package that is available inside this data analysis module. When I click on data analysis, I can see the ANN toolbox. When I click on ANN toolbox, I can see here all the functions have been listed here. And then when I click on install, this package will be installed. I have now chosen to install the ANN toolbox, which includes functions for dealing with artificial neural networks. Now this is when I have given install, this has started the downloading process, which will take a few minutes depending on the size of the package. Here we can see that the package is being installed. Installing is being shown here. So now here we can see that this message has come that installation done. Please restart Scilab to take changes into account. Now if we go back, here we can see on the right hand side that it is showing that this toolbox has been installed here. So all the additional toolboxes or modules that we download or install and be shown in the right hand side. Now this will give the list of the available packages for installation. If you want the list of available packages to be displayed in the console, then we can type this command atom list in the console. Now let us see how we can remove a package. So for removing a package, again we need to open the GUI, the module manager. So we'll go to applications and click on module manager atoms. Now suppose we want to remove a package, let's say this ANN toolbox only we want to remove, then we will click on this and here we can see this remove option is available now. So when we click on remove, this will remove the package. So here we can see remove done. Please restart Scilab to take changes into account. So in this way we can install and remove multiple packages that are available in this Atoms Manager. So here we can see we have packages for data analysis, data handling, differential equation, image processing, image instruments control, signal processing, XCOS. So many others are available. Now that we have covered the key concepts in this part of the tutorial, let us take a moment to assess your understanding with a couple of quick multiple choice questions. This will help you review and reinforce what we have covered in this tutorial. What is the default variable name in Scilab that stores the result of an operation? Take a moment to think about your answer. The correct answer is option C, ANS. Here is the second question. How can predefined constants be accessed in Scilab? Take a moment to think about your answer. The correct answer is option C, using the percentage symbol before the constant name. Here is the next question. Which window in the Scilab environment displays the details of created variables? Take a moment to think about your answer. The correct answer is option C, variable browser. Let's look at another question. Which tool in Scilab is used to write and save multiple lines of commands? Take a moment to think about your answer. The correct answer is option B, Synodes. Here is the next question. Which command is used to display a list of available atoms packages in the console? Take a moment to think about your answer. The correct answer is option A, atoms list. Here is another question. What does atoms stand for in Scilab? Take a moment to think about your answer. The correct answer is option B, Automatic Modules Management for Scilab. Here is the next question. What happens when you enter a command in the console without a semicolon at the end? Take a moment to think about your answer. The correct answer is option B. The result is displayed in the console. Now, here is the last question. What is the file extension of script files in Scilab? Take a moment to think about your answer. The correct answer is option C, .sci files. If you got the answers right, good job. If not, don't worry. You can revisit the explanation in the video.
In this lecture video, we have presented a comprehensive overview of Scilab, exploring its features and capabilities in detail. This video compared Scilab with similar numerical computing environments like MATLAB, highlighting their key differences. The lecture introduced us to the basic syntax, essential commands, and fundamental topics such as handling .sci files, executing scripts, and using mathematical operators and constants. Additionally, it also covered the installation and removal of packages that extends Scilab's functionality. Thank you for watching this video.